Okay, welcome back. Again, we are working on displaying and summarizing quantitative data. In Summer Assignment 1, we learned that when we summarize the distribution of quantitative data, we need to discuss shape, center, spread, and any unusual features in the graph. Again, shape, center, spread, and any unusual features in the graph. When we talk about shape, we want to talk about, is the distribution symmetric or skewed? If the distribution is symmetric, we're going to use the mean to represent the center of the distribution and the standard deviation to represent the spread. If the distribution is skewed, then we would use the median to represent the center of that distribution and the IQR, which stands for interquartile range, to represent the spread. So let's take a look at what a roughly symmetric histogram would look like. Okay, and again, you can see that bell-shaped curve. We're going to talk a lot about that in AP Statistics. This distribution is said to be skewed to the right because when you try to draw that curve, we have this tail that seems to fall to the right. And here, this distribution is skewed to the left. So let's work together through a problem. Take a minute, please, and enter these data values into your calculator. Did you forget how? All right, let's go through it together. So let's take out our calculator. Let's start on our home screen. And let's click the Statistics button, S-T-A-T, it's right here. We get this menu, Edit, and we're just going to hit either the number 1 or the Enter key. And we're going to get a whole group of lists. Now you might have something in your list 1 from the beginning of the summer when we did Work Together 1. So if you want to clear a list, let me show you how to do that. I already have all my data in list 1, so let me show you how to clear list 2. You go up to the top of list 2. Okay, so see how the top of list 2 is highlighted? You hit your clear key, and then you hit enter, and then list 2 is cleared. Okay, so just clear your list 1 and enter the data values for this prompt. If you need to, please pause the video to do so. Okay, welcome back. So all of our data has been entered into list 1. Let's take a look at what this prompt is about. Here are the number of pieces of mail received at a school office for 36 days. In part A, they ask us to create a histogram for these data. So we're going to be learning how to create a histogram on our graphing calculator. So all our data is in list 1. Well, how do we create a histogram? Well, first we have to figure out how many bars we need in our histogram. And roughly we can determine the number of bars by taking the square root of n. And n is our number of data values in our set of data. So here it says we have the number of pieces of mails received in 36 days. So our n is 36. We have 36 data values. So the square root of 36 is 6. We'd expect about 6 bars. Well, I also need some information, like what's my smallest data value? What's my largest data value? Well, remember where we could find that. There's lots of different ways, but let's go back to our stat key, over to calculate, and if we calculated our one variable statistics, it's going to give us information like our mean, median, that kind of stuff. Yes, my data is in list 1, and I'd like to calculate all my one variable statistics. Oh, here's my mean, which they ask us for center and spread later, and we have to figure out based on the graph of the distribution which center we're going to use. Here's my standard deviation. Let's arrow down. Here's my 5-number summary. If I wanted to create a box plot, I'd need my 5-number summary. But here's my minimum value and here's my maximum value. Those are going to be important when I'm determining like bin width and that type of stuff. So take a minute and write those down. Our minimum value is 52, our maximum value is 151. Okay, so far we know that we need approximately 6 bars. We determined that by taking the square root of n, and n is the number of data in our prompt. Okay. Now we need to determine bin width. How thin or how wide are each bar? Well, the easiest way to determine bin width is to take our maximum data value, which we just found, 151, to take away our minimum data value, 52, divide it by the number of bars, which was 6, and we approximately get a bin width of 16.5. All right, so I need about a bin width of 17, but yeah, well, let's go with a bin width of 20. That's close enough, right? 17, 20, not so far off, right? My minimum value was 52. I'm going to round that to about a 50. That's going to be my X min value. So if I did 50, and I know I need 6 bars, so let's take out our calculator again. I'm going to go back to my home screen. If I started with a minimum value of 50, and I needed to add 6 bars, and each bar was 20 units wide. Oh, here we go. I know the maximum data value would be 170. So that gives me a range of values that I'm going to create my window with for my histogram. So let's go here to second y equals stat plot. I'm going to hit enter. I'm going to turn my plot on. I'm going to arrow down, make sure it's on histogram. I want to make sure that my histogram's in list 1. Okay, and it doesn't matter which color your histogram is. Let's go to our window. Notice I changed my window. Make sure you change yours. I'm saying, hey, my minimum data value is 50. My maximum is going to be 170. My X scale is 20. Now, how about my Y minimum? Well, the smallest possible number of pieces of mail would be 0, but I'd like to see a little bit below that in my graph. And I said the maximum pieces of mail is 10. Well, maybe it's bigger than that. I could make that 15. I could make that whatever I want. But I don't, let's see how this looks. All right, so now I've changed my window, and that's very important when creating a histogram. Okay, and now I'm just going to simply hit graph. Okay, so do I have 6 bars? 2, 4, 6. I do. I can see all the bars in my graph window. That makes me happy. If I hit trace, I see that there were 4 pieces of mail. There were 4 days where there were between 50 but less than 70 pieces of mail. So there were 4 days that there were between 50 and 69 pieces of mail, because you can't have 69.5 pieces of mail. That wouldn't make sense, right? You either have a piece of mail or you don't. There were 8 days in which I had between 70 and 89 pieces of mail. There were 10 days which we had between 90 and 109. That says it's less than 110, so 90 and 109. Okay. There were 8 days that the office received between 110 and 129 pieces of mail. So hopefully you're understanding how to read this histogram. Okay, so how are we going to transfer that knowledge onto paper? Okay, so now we have this beautiful histogram in our calculator, and we have to be able to recreate it and put it on a piece of paper for a quiz and or test. And we need to be able to interpret the data that we see in front of us. So let's take a look. We know all good graphs need a title. The axes need to be labeled. Okay, so I just took a screenshot of my calculator. OEB. That didn't work. Better? Good. So here's my title, number of pieces of mail received in the school office. The x-axis is number of pieces of mail. I should have put of mail. The y-axis is number of days. You can clearly see there were 1, 2, 3, 4 days that we received between 50 but less than 70 pieces of mail. Originally, I had 50, 70, 90, 110, 130, 150, 170 here, but then it became too squished and it wasn't easy to read. So I just labeled the beginning of each bar, of every other bar. So this would be 50, this would be 70, this would be 90, and that is perfectly fine. I think the graph is clear and easy to read. Okay, so now we've created a histogram, and our histogram is beautiful. We have labels on our X and Y axes. We have a title on our graph. We, in fact, have 2, 4, 6 bars, and the approximate bin width was, somewhere between 17 and whatever, and I picked 20 because it's a nice even number. So describe the shape of this distribution. Well, I would say that this distribution is roughly symmetric, right? You could see how you could draw a bell here. All right, so let's go with roughly symmetric. And we know if our distribution is roughly symmetric, we are going to use mean to describe the center of the distribution and standard deviation to describe the spread or the variability. So let's again take a look at our calculator. How would we get there? Well, just a reminder, it's our stat key. Arrow over to calculate. You can again either hit the number 1 or hit the enter key. Yes, my data was in list 1. And here is my mean. So on average, the school received about 100, we would put 100.25, but we know it's 100 pieces of mail. And with a variability of about 25 pieces of mail. So, somewhere between 75 and 125 would, be an expectation. So that's what that means, the variability, the spread about the mean, okay? So because our data was roughly symmetric, we're going to use the mean to represent the center and the standard deviation to represent the spread. Okay, so again, here's our mean, X bar. Here's our standard deviation. This is S with a little subscript X. That's the standard deviation of our sample. Okay. Again, I could take a picture of that. Okay.